Hello, tech enthusiasts. Welcome back to your favorite YouTube channel, My Project Ideas. I am Simran, and today we are exploring the intriguing realm of data structures and algorithms, where you are gearing up for a coding interview or aiming to enhance your programming powers. This video has got you covered. So, today, let's break down these complex concepts into simple, easy to understand pieces. So here guys, stay tuned. So today's topic is all divisors of a number. I suppose you guys particularly know what divisors of a number simply imply. The number, suppose a number is 4, so the divisors of the number are the numbers which divides the number 4 completely, like 1, 2 and 4. So what are the divisors of the number 4? They are 1, 2 and 4. Simple, easy peasy. So let's move forward and let's see what interesting stuff we do have for this concept. Here we are. So suppose we have given a number 50 and we have been asked to find out all the divisors. What do? Just we check out the numbers which divide the number 50 completely. Those numbers must be less than or equal to 50. So we have a set of numbers like 1, 2, 5, 10, 25 and 50. It divides the number 50 completely. So these are the divisors of the number 50. Certain examples are there, like for a number n is equal to 10, the output what we get is 1, 2, 5 and 10. For 100, we get 1, 2, 4, 5, 10, 20, 25, 50 and 100. For 125, we get 1, 5, 25 and 125. Simple guys, no brainer. Next. So how do we check whether a number is like prime or not, whether it has divisors or not? So basically a prime number will have two divisors only. It will be having two factors, that is 1 and the number itself. So how do we like find out that a certain number has divisors or not? A naive solution will be to iterate all the numbers from 1 to n, and we have to check whether a number divides n and we have to print it. Simple guys. It's same as the thing which we did in the previous lectures, like the prime number video. So it's very quite simple. So how do we code it? And guys, the time complexity of this code what we are gonna write will have big O of n time complexity, and the space complexity will be big O of 1. So guys, the algorithm is written here to iterate all the numbers from 1 to n, check if the number divides n, and then print it. Simple stuff, no brainer. So I'll recommend you to just pause this video for a minute and proceed towards your coding platform, your text editor, your IDE, and just write down the code. Then you can compare the code with me. Okay, cool. So let's move to the IDE, the text editor. Here we are. So I've already created a file called printdevices.python. Now let me write the code. Print divisors. Let's take the parameter n. Simple iteration for loop for I in range from 1 to the number plus 1. I forgot a colon here again. Then if n mod I, so what does this give the like? If we divide a number or if we modular divide a number by a certain number, we get the remainder. So if the remainder is double equal to 0, then we have to print that number. Simple. Print I, and let's end it. Okay, got it. Next. Simple, it's done. Then let's write the driver code. If, so guys, we already wrote the code. Let's put the name double equal to, let's write main here, and let's print. At the printing statement, print the divisors of 100 are, because I'm gonna take the number 100. Done a mistake here. Divisors. I have left an R. Okay, no issues. And now what I'm gonna do is I'm going to call the function. In divisors, the number will be 100. Okay, let me save it and now let's run it. Okay, let's clear the terminal first so that you will get to know. Here run and we have the answer in the terminal. So the divisors of 100 are, it's written here. 1, 2, 4, 5, 10, 20, 25, 50 and 100. Got it? Let me clear the terminal because we are gonna write the efficient code as well. Okay. Let me open the file again. Okay. So this is done. I hope you guys also got the answer what I wrote. So if you did not, then no worry. Just check out the code which I have written. You'll get an idea. Next, can we improve the above solution, guys? So the time complexity here was big of n. So can we like improve the time complexity? Can we like decrease the time complexity? So let's find out the answer. So the divisors in pairs. So the divisors of n of a number n always comes in pairs. Like for 100, the divisor pairs are 1 and 100, 2 and 50, 4 and 25, 5 and 20, and 10 and 10. So if you multiply these pairs, you will get the number whose divisors you are going to find. How do we speed up the program? So do not iterate up to n, iterate up to square root of n to find the divisors. Then to find out the divisors, you do need not iterate up to n. If you're iterating up to n, that's why your time complexity is big of n. So if you iterate up to square root of n, your time complexity will be square root of n only. So for each I from 1 to square root of n, if I will divide n without a remainder, then I and n by I are divisors. Suppose if 5 divides 100, the remainder is 0. So 100 by 5, that is 20, will also divide 100 without keeping any reminder. Got the point, right? Like for example, once again, suppose 2, not suppose 2 divides 100, the remainder is 0. 100 by 2, the remainder will come 0. So then the pair of 2 will be 50 because 100 by 2 will be 50 and 50 will also divide 100. So this is a simple trick. Not a simple trick, actually it's a trick which will decrease your time complexity. A smart work. So how do you handle the equal divisors like 10 and 10? This can't be counted as two different numbers because 10 is a single number only. In this case, count a single 10. So what are the steps? First, initialize, start with an empty list of divisors, then iterate from I to square root of n. So if n mod I is double equal to 0, add I to the list of divisors. If I is not equal to n by I, then add n by I to the list. This is to like take care of the equal divisors issue. Here, this step. Okay, then output what you have to do? Print or return the list of unique devices. Got it? So I guess the algorithm is understood. It's understandable by you. You guys got to know what is there in the algorithm. So now your task is to write down the code. Pause this video and first write down the code. I'm gonna write it as well. But you pause this video and write down the code by yourself. Then come back and compare the code with. Okay. So let's move to the text editor and let's write our code again. Let me create a new file here. Let me write print divisors efficient dot python. So we have another file here, and now let's begin writing our code. First import math because we know that we are gonna use the square root function. Then print divisors, take the parameter n here. Then write the iteration like the loop for I in range 1 comma square root math dot sqrt math dot square root of n plus 1. Then if n mod I double equal to 0, then what do you need to do? You need to check it again. Did I do something mistake here? Yeah, I have given an by mistake I wrote an I. Okay. So if divisors are equal, then you need to print only once. We already discussed about it. So let's handle that case first. If n integer divide I is double equal to I, then you have to take that case once. So print I, let's end it. Okay. Okay, got it. Next step, else part. Okay. So if now the pairs exists, so what we have to do? We have to print the pairs, like print I and n by I. Okay. Next and simple guys. It's very simple. If you understand the algorithm, writing a code is piece of cake only. So we are already done with the algorithm here. We are already done with the gist of the code. Now we need to write the driver code. So let's write the driver code, which is simple. Name double equal to main print the divisors of 100 are. Now let's call the function in divisors and put the 100. Okay, save it, run it. So you can see the divisors of 100. Now you can see that it occurs in pairs like 1 and 100, 2 and 50, 4 and 25, 5 and 20 and 10. So it's like not in a sorted order guys. So it doesn't look good when we read the divisors. And a normal person can't just say that it's in pairs because we studied the algorithm before, so something came into our mind that these occurred in pairs because we wrote the code, we understood it. But this is not in a sorted order and it doesn't look good. So the next step that we're gonna do is we're gonna sort these things. We're gonna make it look good. This is also correct, but now what we are gonna do is we're gonna make it look good. So let's open our PPT again and let's see if we can do something else. So what we did was the time complexity, we reduced it to big O of square root of n, and the auxiliary space was big O of 1 only. Now the final thing is we are going to print all the divisors in sorted order with the same time complexity, that is big O of square root of and auxiliary space into big O of 1. Got it? So if you guys already know how to sort it, how to write down the code, please go forward and write it. And others, if you do not have any idea or if you are still struggling, no issues, just be with me. You will get to know. Efficient sorted, not by. Okay. Now let's begin writing. Import math def print divisors. Let's put the parameter n, then I is equal to 1. So initialization of the variable I is equal to 1. First, let's take a loop to find and print all the divisors that are less than square root of n, which we did in the previous code also. So while, now we are taking a while loop, I cross it, that is up to square root, because we were taking up to square root. So this is another way of writing. While we are changing into while loop, what we are doing is we are multiplying I by, that is I square, which will be less than n. Okay. If n mod I is double equal to 0, here we have to print what? I comma n. So you understood, right? We were taking up to square root of n, but here as we are taking I square, that's where we are taking up to n. Same thing in a different format. Now incrementing the value of I, done. Then Let's adjust the I if it is a perfect square. If the number is a perfect square, what do we do? So we have to like write the code in such a way that we are taking it one time. Okay. So if I minus n by I is double equal to 1, checking it whether it's a perfect square or not, then I minus equal. Okay. This is for the perfect square case. So because we did not write both these, suppose 100. So 100 has a divisor 10 cross 10 as well because 100 is a perfect square. So in that case, you have to take the divisor as 10 only, not 10 and 10. It will be repetition. Now, let's take a second look to find and print all the divisors that is greater than square root of n. Okay? So some divisors may be greater than the square root of n. So let's consider that case also. Let's take a while loop. I is greater than equal to 1. If n mod I is double equal to 0, then you have to print what? The integer division, but that is n by I, and let's end it. Simple guys, just understand the concept, understand the algorithm, you're good to go. Then I minus equal to 1. Simple thing. So we are done with the code now. Let's write the driver code. If name is double equal to name, print the divisors of 100 are print divisors, and let's put the number 100. Okay, now let's run it and see. So now you can see that they occur in a sorted order. So I hope the theory section was clear to you as well as the coding section. The algorithm was also quite understandable. The coding also was simple. I hope you could understand it properly. So for today, let's wrap up this session. And for more interesting project ideas, stay tuned, guys. Until then, happy coding, happy learning, and keep rocking. Thank you and have a great day.